We will explain basic working principle of bipolar junction transistor. Now, we will try construct the semiconductor transistor. There are two types of semiconductor transistor. There are NPN transistor and PNP transistor. For checkers understanding, we will draw an NPN transistor. There are two N-type region and one P-type region in between them. One N-type region is highly doped. The size of this region is moderate. We may call this region as emitter. The middle P-type region is lightly doped. We make this region very narrow. We call this region as base. Other N-type region is moderately doped. The size of this region is largest among all regions. We call this region as collector. Now, let us first connect the positive terminal of DC voltage source to collector and negative terminal of the same voltage source to the emitter. In this situation, the PN junction between collector and base becomes reverse based. The PN junction between base and emitter is forward based. Let us consider the voltage applied between collector and emitter VCE and the voltage drop between reverse base collector base junction is VCB. The voltage drop across the forward base reference junction is VPE. Addressed situation, the voltage VP is things and it equals to forward base voltage of PN junction. If we consider it a silicon transistor, the forward base voltage of PN junction would be 0.7 volts. Thus, VCE equals to VCP plus VPE, which implies this VCE equals to VCP plus 0.7 volts. That equation inducts the entire applied voltage between collector and emitter expecting 0.7 volt drops across the reverse-based collector base junction. So, whatever may be the applied voltage between collector and emitter, there would be a potential barrier of 0.7 voltage between emitter and base. Because of that, no electron can cross the base emitter junction for any applied collector emitter voltage, so no current can flow through transistor. Now we connect negative terminal of the collector emitter voltage source to the negative terminal of another smaller DC voltage source. We connect positive terminal of the second voltage source, the base region. After that, the total scenario will change. If we increase the voltage between base and emitter from 0 after reaching the base emitter voltage just above 0.7 volt, the free electrons start crossing the junction from emitter to base region as we told earlier. The emitter is highly doped. The number of free electrons available in the zone is quite huge. So a large number such free electrons cross the junction and appear in the base region, but the pile is very lightly doped, so the number of holes available in this region is quite low. So maximum free electrons come to this region do not find hole to recombine. Only few, about 2% to 5% of the free electrons recombine with available holes there. These electron hole recombinations contribute to the base current, which certainly 3 legs emitter and both instead read 98% to 95% of free electrons cross the collector base junction due to their kinetic energy gained from electrostatic first base emitter voltage. The accessory electrons in the base region can easily cross the reverse Mills collector base junction because these free electrons appear as minority carrier in the base regions, and reverse base collector base junction does not oppose the flow of these electrons in collector region. Now, if we increase the base emitter voltage slightly, the number of free electrons cross the junction is also proportionately increased. the base current is still 2% to 5%. The total current here, we see that total electrons enter into emitter strips or steam passed from emitter undeviated into path. Very few of them are combined. We hold in the passed region and contribute base current. Maximum of them cross the base collector junction and contribute collector current. So, emitter current is the sum of base current and collector current. The ratio of collector current to base current is known as current gain. In common and in commode and digital negative return their loss between collector to IC divider IP. This was the basic concept of transistor.